All right, guys, we're going to be taking a look at some right triangle trigonometry. We can use trigonometry to find sides and angles of right triangles. We can also use some other laws in trigonometry to find sides and angles of non-right triangles, which we'll be doing in another video. For now, we're just going to be looking at the basic right triangle trig using sine, cosine, and tangent, our three trig functions that we cover in IB math. So we got sine, cosine, and tangent here. Okay. When setting up your trig ratios, we always do so based off an acute angle in a right triangle. So we would never use the right angle. We'd always use, in this picture that we have off to the side, either angle A or angle C. And I set up below, going ahead and doing this based off angle A. Okay. Sine of A always refers to the opposite side over the hypotenuse. Cosine of A always refers to the adjacent side over the hypotenuse. And tangent of A always refers to the opposite side over the adjacent side. Okay, and the way this works, we need to kind of set it up with our triangle. I always tell students, circle your reference angle so you know where you're starting. In this case, my reference angle is the angle here in parentheses. So I'm going to circle angle A, okay? And my hypotenuse will always be the side across from the right angle. That'll never change. I'm going to go ahead and mark that, hypotenuse. Okay. Once I've labeled my hypotenuse, I'm going to look for my opposite side, and that's the side that's opposite my angle. So if I draw a little angle, or draw a little arrow directly across from that angle, my opposite side here would be the side that I have labeled 6. Okay. And then by process of elimination, that leaves my bottom side here to be the adjacent side to angle A. The other way you know that it's the adjacent side is the adjacent side is always the side between the angle that you have as a reference angle and the right angle. Okay. And I can now set up my ratios here. So if I want to set up my ratio for sine, I need the opposite over the hypotenuse. That would be 6 over 10. For cosine, I need adjacent over hypotenuse. So that'd be 8 over 10. And for tangent, I need opposite over adjacent. So that'd be 6 over 8. Okay. When we go to actually solve for a missing side or a missing angle, we would have a variable in here somewhere, okay, that we would be able to solve for. And we'll do a couple examples of that in a minute. The other thing I want to talk about is when we have specific application questions, which, you know, the IB is very used to doing. We might have something called an angle of elevation, angle of depression, and you just need to know how to kind of draw that triangle out. The angle of elevation and depression is always based off of the horizontal line of sight. So I'm going to draw a little stick figure guy here. Okay. And imagine he is looking out directly. The angle of elevation, if you want to think about it, horizontal line of sight, the angle of elevation is how much that person then looks up from their horizontal line of sight. So if they're looking up that direction, okay, that would be kind of the triangle I get based off the horizontal line of sight. And my angle of elevation, let me get a smaller eraser here, would be the angle highlighted right here in red, because that is how much he tilted his eyes up or his head up when he looked up. It works the exact same way for angle of depression. Okay, so if I draw my little person, again, horizontal line of sight, if your head is stationed properly. Okay. Angle of depression, rather than looking up, it's how much this person tilts their head down or looks down towards the ground. So then if we put his line of sight down, we end up with this right triangle instead, okay, where my right angle is here on the right, and the angle of depression would be the red angle here. Okay. If you end up with an application question of angle of elevation or angle of depression, these are the triangles really that they're typically referring to in those, okay? And we're gonna do some practice problems here in just a second. But if you have to pause, kind of rewind, or take a second to copy anything down, feel free to do so. Okay, first we're gonna do a regular application of trig, okay? Regular trig, we call it regular trig when we're looking for a missing side. And for that to work, we would need to have an angle, specifically one of the acute angles. Okay. So let's say in this one, I am looking for my hypotenuse. I'm going to put a little x there. Let's say I have an angle 25 degrees. And let's say my other side that I have is, let's say it's this bottom one here, that's 13. I'm going to go ahead and set up my trig, okay, the reference angle that I have. I'm going to circle it. I'm going to go ahead and label my other side. So I'm going to go hypotenuse here is always across the right angle, and I should probably add my right angle into this picture just to be safe. Okay, it's down here in the bottom left corner. Okay. And then I've got opposite side. And then I've got my adjacent side here on the left. Okay. Once I've labeled those, I need to decide which trig function I want to use. And there's a little helpful acronym to help keep track of which trig function takes which two sides. I'm going to write that up here at the top. We call it SOHCAHTOA. Okay, so that stands for sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So the order of the OH, AH, and OA matter. The thing that goes in the numerator is on the left, the thing that goes in the denominator is on the right. So opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. In this case, if we take a look at our triangle, the two sides that I have something for, I'm going to highlight in green, okay? I have a value of 13 for my opposite side, and I'm looking for my hypotenuse, so that is something I should include in my trig ratio. Okay, so really I have useful things for the opposite and hypotenuse side. I could have a value for the adjacent side. In this case, I don't. Okay, so I'm going to set up my trig based off the opposite and hypotenuse. And when I do that, okay, opposite and hypotenuse, that refers to sine. So I'm going to go sine 25 degrees, angle is going to go in that parentheses, equals opposite over hypotenuse. Okay, so there's the setup for my trig ratio. Now I just need to solve for my variable. And to do so, I'm going to multiply x on both sides to get it out of the denominator. That's going to give me x sine of 25 equals 13. I still need to get my x alone, so I'm going to divide sine of 25 on both sides. And it's going to bleed over a little bit into the other space, but that's okay. And I'm going to get x is equal to 13 divided by sine of 25. Okay. Now, as with any problem, we're going to probably want to go ahead and get the decimal answer and round it to 3 significant figures. So I'm going to take 13 divided by sine of 25. Okay. Make sure your calculator's in the proper mode. We should be in degrees. Radians is something that HL will use, and we'll talk more in other sections. But in this case, we want our calculator to make sure it's in degrees. So 13 divided by sine of 25. If you're an SL student, you'll only ever use degrees. We won't ever refer to radians. And if we round this value to 3 significant figures, we should get 30.8, whatever units the problem technically has, okay? So that would be the length of my hypotenuse in this case. We also have inverse trig, okay? And we use inverse trig whenever we're looking for a missing angle. And in order to do that, we're going to need at least two sides. And we got a little story problem here, kind of similar to what we might see as an IB exam question, though we probably have a couple more parts than what it has in this particular problem. So it says a lighthouse shines its light on a boat in the water. Okay, I'm going to go ahead and draw a little lighthouse for a second. Maybe cliff. Okay. So there's my little lighthouse, and it's shining its light on a boat in the water it's wanting us to find what is the angle of depression. So I know I should have a horizontal line of sight. It's shining its light down into the water. And here then is my angle of depression triangle with my right angle there in the top right corner. And they're wanting me to find that angle there. That's going to be my x. Okay. They tell me the lighthouse is 65 feet tall. So if this is 65 feet, that translates directly across 65 feet. And then it says if the boat is 65 feet from the base of the lighthouse, we're going to change that actually. That's a typo. We're going to go if it is 80 feet from the base of the lighthouse. Okay, so if this is the base of my lighthouse, directly across is 80, that matches up top, 80 feet. Okay, I'm now going to set up my trig ratio, but I need to identify my sides first. I'm going to switch to green. So if this is my reference angle, I've got opposite. My hypotenuse is here, and there's my adjacent side. And again, adjacent side is between the reference angle and the right angle, so that is another way we can identify that as the adjacent side. And the two sides that I have something for are my opposite and adjacent side. That refers to tangent. So I'm going to go ahead and set up tangent of my angle equals opposite 65 over adjacent 80. Okay. I need to get that x out of the tangent, and to do that, I use my inverse tangent function on my calculator. So inverse tangent of both sides. That's going to release the x from inside the parentheses, which is the angle we're looking for. And on the right side, okay, so those will cancel there, I get tangent, inverse tangent of 65 over 80. And I type that into my calculator. Okay? You can use the second button on your calculator to get to the tangent, or if you're using your graphing calculator, there's probably a button for all your trig functions. So I'm going to hit inverse tangent 65 divided by 80, and that's going to give me 39, rounded to 3 sig figures, 39.1 degrees. And it's not uncommon that they ask us to round to the whole degree. It really just depends on the problem and if it states something different than 3 sig figs. Okay. Again, if you ever have any questions, feel free to ask in class. This is just kind of a brief overview of all of the right triangle trig. Okay. We'll do some practice and things like that, but you're welcome to ask in class, and thank you all for watching.